Hi everyone. In number 7, we're given basically a rectangle inscribed in a circle picture. And the situation is supposed to be that the circle is a log. So this is actually visualized 3D, right? We're just looking at a cross section. It has a radius of 30 centimeters. And we're trying to cut a rectangular beam out of that, with the goal being that we want the strongest possible beam. And we're given a little bit of information about how strength is actually calculated. So let's say S is the strength of the beam, and we're told that the strength is proportional to WH squared. So one way to say that would be that strength is a constant multiple of WH squared. That's what proportional means. K is a constant. So you can either do this and just work with constant K. That's actually some kind of nice practice for a 3.3 type problem. Your other choice is to say S is proportional to WH squared. So you can just use that squiggly for proportional to. And then you can work on this just as if it was an equal, but you're not claiming that S is exactly equal to WH squared, just that it's proportional to. So I don't really care if the K is there or not, but just be aware that that's what that would mean. Okay, so this is great, but we don't want so many variables. The K is fine because we're just going to treat it as a constant, but we can't have a W and an H in this formula, so we need to figure out in this picture exactly how are we going to relate W to H so that we can eliminate one. You can kind of see that at some point I scribbled on the picture that's in this PDF. So what I know is that I have dimensions of a rectangle. So this is the width and this is the height. And I can't just pick any WH combination because it needs to fit inside this radius of 30 centimeters that I have on this circle. So you can either make a little triangle or a big triangle. I think I'm going to go with the big triangle, but it's really up to you. You could also make this little one right here. I like the big triangle because then I won't have to use a W over 2 and an H over 2, but I do have to be a little careful because now I can't use 30. I need to make sure I'm using 60. So here's this beautiful little right triangle, and I can say that W squared plus H squared is equal to 60 squared, which is 3,600. And I think I'm going to keep the W. So I'll say H squared is 3,600 minus W squared. And if you're paying attention, you can actually quit there because H squared is what's in our formula. So if we just leave it like that, we can say strength is equal to K times W times H squared, which is the same as a 3,600 minus W squared. Okay, so I'm going to go ahead and distribute before you take the derivative. You don't have to. You could use a product rule, but it just seems like a pretty quick step. So I will say that S is 3,600 kW minus kW cubed. And when I take the derivative, remember K is just a constant. So imagine if the K wasn't there at all. We had 3,600 W. The derivative would just be 3,600. The K just kind of sticks to that 3,600 and behaves in the exact same way. And similarly for KW cubed, the K is a constant multiple, so it'll just hang out. That 3 will drop down in front, and it will become a W squared. This derivative is never undefined, but let's set it equal to 0. And we can say, okay, I'm going to add 3 kW squared to both sides. So 3,600K equals 3 kW squared. And then I can divide both sides by 3K. And 3,600 divided by 3. Okay, so I'm going to get 1,200 equals W squared. So W is equal to the square root of 1,200. Okay. And it would be plus or minus, but we don't want a negative width of our rectangle. Okay, I'm staring back at I was good and I did my calculator work, but my brain didn't work and I did 1,800 instead of 1,200. So let me just check really quick. I think the rest of my stuff should be okay. Square root of 1200 is roughly 34. So 34.64. And I wanted to have that idea so that I could kind of picture if it made sense in this problem. W certainly can't be bigger than 60 because 60 would stretch all the way across and we wouldn't have a rectangle at all, even at 60. Anything bigger than that doesn't fit inside the log. But 34 should certainly fit inside the log, so that seems fine to me. Now I need to verify that I have a maximum. And then I'll need to make sure, find the width and height, that I give the dimension. So I'll also have to find a height. So S of, what are my extremes? The skinniest beam that we could cut out of this is, I guess, a non-beam, right? So the extreme is that W can be 0, and then you're just getting this nothing. You basically cut away everything. And then the widest we mentioned already, the other extreme, is that if we let W be 60, we've cut away all the height. So those should be what we're plugging in for endpoints. And then we'll also check what happens with the 1200. Okay, so these actually work out nicely if you go back to the factored form of your formula. If you plug in 0, you get k times 0 times 3600, which is 0. If you plug in 60, you get k times 60 times 0. 3600 minus 600 squared is 0, which is also 0. So let's see, anything positive here would tell us it's a maximum. But we can actually plug in and do a little checking if you want. So we have k times root 1200, which can be simplified. I'm not worrying about it too much right now, times 3600 minus root 1200 squared, so 1200. So we're getting k times root 1200 times 2400, definitely bigger than 0. So I think it's safe to conclude at this point that this is our max. Okay, so last step, we know that our width should be about 34.64, let me check what my units were, centimeters. We also want to know what our height should be, and our height should be, actually it's this thing right here, it should be, it's the square root of that thing. So our height can come from this right here. We could say that height is equal to the square root of 3600 minus W, which is root 1200 squared. So we get 3600 minus 1200, which is 2400. We want the square root of that. I missed a 4. 2400. Okay, so the square root of 2400 is about 48.99, really close to 49. 48.99 centimeters. So this pair right here is our answer. Okay, thanks for watching.